Everyone, my name is Jimmy Yang. Today I will talk about a paper authored by P. Clark, CM Elliptic Curves, Volcanoes, Reality and Applications, Part 2. So I will read to you the main result in section 1.1. This paper is a direct continuation of another paper that is in version 1, which determine the delta Cm locus on the modular curve x0 of m, n defined over q. So the key point is delta Cm locus. That is, there is a series of elliptic curve whose determinant are the same, which is delta, and there is a delta Cm action acting on the elliptic curve, all of this kind of elliptic curve, such that the action is the same as complex multiplication, and the action is can be viewed as a ring, an endomorphism ring, and the order of this endomorphism ring has the same discriminant, and the discriminant is delta. That is the meaning of delta Cm locus, and you can view it as an orbit. There is a Galois group acting on the J invariant of the J delta, such that all of the J delta are Galois conjugate. So they are in the same orbit. Okay. For delta, the discriminant of an order in an imaginary quadratic field K, different from Q adjoint with square root of -1 or Q adjoint with square root of -3. This work also gave a completely explicit description of the primitive residual fields of delta Cm close point. So another concept here is close point. A close point can be viewed as a series of points. So a close point is an orbit of the Galois action. So, i.e., the residual field Qp of delta Cm point P belongs to x0 of m, n, for which there is no delta Cm points P prime, such that the Qp prime embedded into Qp as a proper subgroup, proper subfield. That is the meaning of a primitive. Finally, the work also gave an inertness result for the fiber from S1 to S0 over delta Cm points on S0 m, n, which yields a complete description of the multi-set of degrees of delta Cm close points on S1 of m, n over Q. Using only the knowledge of the degrees of primitive residual fields of delta Cm points on S0 of m, n, yields the corresponding knowledge of degrees of primitive residual fields of delta Cm points on S1 of m, n, which is precisely what is needed in order to classify torsion subgroups of delta Cm elliptic curves over number fields of any fixed degree. In the present work, we treat the excluded fields Q adjoint with square root of -1 and Q adjoint with square root of -3 if delta is equal to f squared delta k, and delta k belongs to -3 or -4, then for all m divided n, we determine the delta Cm locus of S0 of m, n over Q, and explicitly determine all primitive residual field of delta Cm points on S0 of m, n over Q. Finally, we show that the fibers of S1 to S0 over delta Cm points are connected. Taken together, the works and the present work gave a complete description of the torsion